Alright, hello everyone. In this video, I'd like to start going over this unit about the electromagnetic spectrum. So it's kind of broken down into three parts. The first part is all about the light. We're going to focus a lot on the color, but we'll also go over the other parts of the electromagnetic spectrum, all the way from radio waves to gamma rays. And then we'll also look at how light behaves when it interacts with things like a mirror or like a lens or prism. So let's start with color. There aren't really any equations you have to worry about for the color part. It's more just remember what your primary colors of light are, which we'll get into when we talk about the labs, and your primary colors of pigment, which we will also cover in the labs and in the homework. You also want to know what the additive property of colors means. So the additive property has to do with the primary colors of light. And what that means is when you mix all those colors together, they give you white light. So they build up to produce white light. And a great example of this is a rainbow. We have the white light coming from our star. And after it rains and we see that rainbow, that white light is being broken apart into all of its pieces, which is the full spectrum, the Roy G. Biv. All those different colors are coming out of that white light. On the opposite side, the subtractive property of colors. This has to do with pigments. And when you mix all the colors of pigment together, you end up with black. Okay? And the way this works is it all has to do with the nature of how pigment and light interact with one another. So white light is a mixture of all these different colors. And pigment is something like ink or dye. So say I'm sitting here in this blue t-shirt. The reason it looks blue is because it absorbs all of the other colors except for blue. Okay, or say I was wearing a yellow t-shirt. It would be absorbing all the colors except for the colors that make up yellow. Okay, so pigment absorbs colors of light and then transmits a specific set of colors. So with the subtractive property, if I mix all of the different pigments together, between them, they're going to absorb all the different colors of light, and you end up with black, or the absence of light. So we scroll down a little bit further here. There's some simulators that we'll end up using. All of these are for the whole chapter, not just for this specific lab. Our first lab, we're going to look at mixing colors. All right. So as you see, I already have the answers in this one. I'll erase them and show you how we got them. So using either of these two links, the Physics Simulation RGB Color Edition or Color Vision, they both end up with the same thing. You can try both of them, see which one you like better. You can do both of them and see if you end up with the same answer. Let's start with our first one here, a yellow school bus. All right, I mean, the school bus part isn't important. What's important is that we want to end up with a yellow school bus. So if I go to the first simulator, you'll see three different primary colors of light, red, green, and blue. And if I mix those three colors all together, where they're overlapping, I end up with white light. Now if I look between the different colors, like red and blue, I get purple, and blue, or actually it's magenta, and blue and green, I end up with cyan, and then green and red, I end up with yellow. So in my first example, I want a yellow school bus. So I don't need the blue, right? Red and green is what makes blue. So if I crank down my blue, you'll notice down here this color is changing. So if I end up getting rid of all of my blue, I end up with a nice yellow. Now what happens if I adjust like my red? So as I crank the red down, you'll notice that color is changing. It's getting more and more green until eventually the red's gone, I end up with just green. If I crank down the green, I'll notice it's turning more and more of an orange color. Okay, but I wanted yellow, so I'm going to crank these up. 100% red, 100% green, 0% blue gives me a yellow school bus. So 100% red, 100% green, 0% blue gives me my yellow school bus. Now, if I go to the other simulator, this Color Vision one, I'm going to want to use the RGB bulbs, red, green, and blue. And this works just the same as the other one. If I crank up my red light here, I'll notice it goes into the eyeball and then it comes over here and I can see the color they are seeing from that light. If I crank red all the way up, I get a nice bright red. Well, looking at our example here, if I wanted yellow, it was 100% red, 100% green, 0% blue. So if I crank up this green as well, I end up with a nice bright yellow. So it's 100% red, 100% green. And the same thing if I crank down the green, it turns more and more orange. Okay, so they behave the same way, it's just a different way of presenting the information. You can use one or the other or both. And then if we scroll down to this next lab, stage lights. This one's really exciting. I like doing something like this in actual class where you can actually see it happening in person. And for those of you in the theater department, might be useful to you in the future. So we are going to be shining light on an object. We have these different actors. We have a black, I'm pretty sure that's supposed to be like a frying pan. Red apple, then again all the rest are fruits. Anyway, we have a black actor, a red actor which is an apple, a green pear, a yellow banana, a blue blueberry, a purple plum, a glass of water, and a white egg. Alright, and what I want to do is I'm going to shine these different colors of light. So I have white, which is red, green, blue mixed together, black, which is the absence of light, red, which is red, green, which is green, yellow, which is red and green, blue, which is blue, magenta, which is red and blue, and then cyan or teal, which is blue and green. I'm going to shine each of those lights on the actor, and I'm going to write down what the actor looks like. So let's look at that. Oh, one thing I forgot, because this is my third time doing this video, and I finally got my audio to work. If we look at the previous lab, if you come to a color like cyan and you don't know what that's supposed to look like, just Google it. I just typed in cyan color and there's a good example of what cyan, either one of those, good example of what cyan looks like, and you can just go with that color. The point here isn't necessarily that you're like 100% exactly right on your color mix. It's that you understand which colors are going in, which colors need to be mixed to make that color. Okay, so back to the stage lighting. Okay, so I'm going to use my blackberry frying pan, whatever this guy's supposed to be, and then I'm going to shine these different colors of light on him. So if I scroll down, my actor, it starts off with the frying pan actor, and I want to shine white light on him. So I click white, and what color does he appear? He appears to be black. So with the white light, the actor appears to be black. Now what if I use the black light? So I go black, it appears to be black. If I use red, green, yellow, blue, magenta, cyan, any of those colors, it appears to be black. And it makes sense because the actor's black. If we tie this into pigments, that means it's a mixture of all the different pigment colors. It's absorbing all those different colors of light. Now what if I switch over to our red actor? So if I click on the actor here, so you tap to change the character, there. You can see the shape, he's an apple. If I shine white light on him, or her, then our apple looks red. So I would type in white light, our red apple looks red. And if I go to the black light, it looks black. So there's no light, I can't see anything. And then I cycle through. If it's red, he looks red, even though it's kind of hard to see because there's so much red light around them. If I go to green, it looks black. Why would it look black here? Well, if I'm just providing green light, there isn't any red light for my pigment to transmit towards my eye. Okay? It's just absorbing the green light, and there's no red to send back. Now, what happens if I do yellow? Alright, well, if we go back to our previous lab, if I make a yellow school bus, it is 100% red and 100% green. So what do you think it's going to look like if I click on yellow light? Well, hopefully you said red. right? So if I shine my apple here with yellow light, the apple looks red. And you'll also notice a little bit of extra detail here. Look at the stem. Okay, yellow is green and red light, so I get to see his green leaf and the red apple. If I go to green, remember he was black, but the leaf was green. If I go to red, the apple's red, but the stem, which was green, is now black. Okay, so blue, one of the other primary colors. If I click on that, everything appears black again. Okay, and then you'll just continue clicking through the different colors of the actor, and you'll cycle through the different colors of stage light, and you'll write down what colors they are, and try not to be passive about it. Try to put some thought into it and try to notice things. I said, this is my third time through, and this is the first time I've actually noticed the leaf. Okay, so take a look at that. If the leaf is a different color, see if you can see it in the different shades. Like here, magenta, I can see the red apple, but I can't see the green leaf. Alright, so that is it for that lab. It's a lab packet worth 2 lab packet points, so you can get that done and get it submitted. And bam, you're on your way. And that'll tie into our optics and light homework. Don't worry too much about this first part yet. Like I said, it doesn't have anything to do with the color, so we'll get into that soon. You scroll down the first part of the homework. Is about color and the electromagnetic spectrum. If you watch this video, it'll go over the 7 different parts of the electromagnetic spectrum, from long wavelength to short wavelength, and you'll just type in each different wavelength as they go. Okay, all the way from radio waves to gamma rays. Then I want you to rank them 1 through 7, with 1 being the lowest energy and 7 being the highest energy. So it's almost a repeat of this. This is a visual way of ranking them from lowest to highest. Here I want you to do it by their name. And then as you work down, okay, we just went over the primary colors of light and a pigment. Look up about complementary colors. And again, this is tied right into the lab. You can even go back to the lab and look at that information. Green pigment, what is it going to absorb and which light is it going to reflect, using our blue, green, and red primary colors. And then once you get to number 7, oh yeah, you can do this one. We'll talk more about prisms later. Let's take a look at this link. It has to do with that rainbow example we were just talking about, so we're going to go to prisms. We're going to put in this prism here. Alright, and yes, okay. Just wanted to see if I gave you the instructions. So if I click on this here, it's going to give me visible light on a black background. And I hit the red button here, and it turns on my laser. So if I'm just shining the laser straight here, I'm getting a straight white light laser. And then if I put it into the prism, I can see that it's breaking it up into the rainbow. Okay, and then does the same hold true for water droplets. What is the speed of light in the following? So there's something, you just look it up, find the speed of light. Speed of light in a vacuum is the one you're probably most familiar with. That's the constant c, speed of light in a vacuum. But it does slow down as it interacts with different materials. And that's why prisms work and other things work, and the different colors slow down differently. Okay, and then describe the behaviors of light when it interacts with these things. And that should be a good amount of progress for today and into tomorrow. I'll continue making some videos. We'll talk more about the waves. Thankfully, we've gone over transverse waves before, so you're going to be familiar with a lot of the parts, and some of the calculations. We'll go into that again. And then in the next video, I'll start talking about mirrors. So then we'll go over the mirrors homework, and then we'll talk about refraction and lenses.